So this is projectile motion with skydiving and then cannonballs later on. So a couple of things you do need to know. Speed is the distance traveled per unit of time. You probably knew that. Velocity, though, is speed plus a direction. So like 10 meters per second north is a velocity, just 10 meters per second is a speed. And acceleration is the change in velocity over a certain period of time. So for acceleration, you can either change your speed or change your direction. Either of those will cause an acceleration. Does that make sense to everybody? Michael? Oh, it's not up on Moodle? Alright, I'll put it up in a second. So gravity tends to pull all objects toward the center of the Earth. Gravitational acceleration is the constant acceleration of any object flying toward the Earth. And this is true of any object, no matter how much it weighs or how much mass it has, as long as you neglect air resistance. So as long as you neglect air resistance, everything falls toward the Earth at negative 9.8 meters per second squared, or negative 32 feet per second squared. We're calling down negative here. Does that make sense, everybody? This is at time 0. Our acceleration is 32 feet per second. We're not moving at all because we're just jumping off the airplane. So you like jump out of the airplane or walk out of the airplane, your initial velocity is going to be 0. So after 1 second, our acceleration is 32 feet per second still. So after 1 second, our velocity is 32 feet per second down. Does that make sense, everybody? So now I've added another 32 feet per second to our velocity because our acceleration is changing at that rate. So our new velocity is 64 feet per second. What's our velocity going to be after 3 seconds? So our velocity after 3 seconds is 96 feet per second. After 4 seconds, we add another 32 feet per second again. So now we're at 128 feet per second. And what's it going to be after 5 seconds? 160. So after 5 seconds, it's 160 feet per second. So what's more daring than skydiving? Cannonball. So a projectile is any moving object that's only under the force of gravity. So if like we threw someone off the roof, they'd be a projectile. And gravity pulls all objects down toward the center of the Earth at the same rate. That's either 9.8 meters per second squared or negative 32 feet per second squared. Some things here. We've got the firing angle is going to be represented by theta, and the initial velocity is going to be v sub I. Make sense, everybody? This is kind of important. If we were to fire someone straight up, it takes them 4 seconds to get to their highest point. At the highest point of their flight, their velocity is 0 for a brief second. What do you think their acceleration is, though? Negative 32 feet per second, or negative 9.8 meters per second squared. So at the top, the velocity is 0, but the acceleration is not 0. Does that make sense to everybody? Because if the velocity and acceleration were 0, it would just be floating up there, which would be kind of cool, but that's not what happens. So on the way up, we slow down, way back down, we speed back up. Now if this was velocity, they should all have negatives in front of them. Negative 9.6 or negative 96, negative 32. 0 doesn't need to be negative. But what I want you to notice here, it takes the same amount of time to go up as to come back down, and the velocity you go up with is equal to the opposite of the velocity you come back down with. Does that kind of make sense to everybody? So if you just fired someone horizontally, they have a constant horizontal velocity. It doesn't change, so they go the same distance every second. Gravity with that, they still go the same horizontal distance every second, but now they're falling as well. The distance they fall each second is going to increase because their velocity keeps increasing. So this is the equation we're going to be using here. So this gives us the horizontal distance traveled, or the initial velocity to go a certain horizontal distance. So vi is the initial velocity they're launched with, theta is the angle, x is the horizontal distance traveled, and g is the acceleration due to gravity, and this is always going to be negative 32 feet per second squared. and horizontal distance will be in feet. Firing angle will be in degrees. One thing you got to make sure when you use this equation is that your calculator is in degree mode. If you're in radian mode for math class, it's not going to go well. And initial velocity is in feet per second. Any questions on that equation? This is just that previous equation rearranged to solve for x. X instead of initial velocity. And our next slide, rearranged to solve for theta. Really, if you just know one of those equations, you're probably fine and can do the algebra to figure it out. Make sense to everybody? Alright, any questions over anything in this PowerPoint? The big things to know are those three, really just one of those three equations at the end, and what all the variables mean.